This is a quick review for Chapter 1, Lines and Circles. Line. The first question, if we have the question, determine the slope of the line that passes through the 2 points, -2 and -3, and the other point, which is 3 and 1. Find the y-intercept and then sketch the graph of the line. We start by using the slope formula, where we use m, which is equal to the difference of the y's divided by the difference of the x's. So we find the slope of the line by having, for example, the second point as x1, y1, and the first point as the x2, y2. So we have the difference of the y's. So we take 1 from the second point minus 3 from the first point. So y1, which is 1, minus y2, which is -3, divided by x1, which is 3, minus -2, that gives us 1 plus 3, divided by 3 plus 4 plus 2, which is 4/5. Now we have m, and we have 2 points. We can find the equation of the line using the formula of y minus y1 equals to the slope of the line, which we already calculated in step number 1 here, multiplied by x minus x1. So y1, x1 can be the point 3, 1, or it also can be the point -2, -3. It doesn't matter which point you take. So we substitute in the formula using the point 3, 1. So we have y minus the 1 from the point 3, 1 equals to the slope, which is 4/5, multiplied by x minus 3, and we do the math. Then we have 5 multiplied by both sides, so 5y minus 5 equals to, and here we have only 4 multiplied by x minus 3, so it's 4x minus 4 times 3, which is 12, and then we leave y on the left side and we take everything to the right side. So first we took -5 to the other side, so we have -17, then we divide everything by 5 to have y equals to 4/5, which is the slope, times x minus 17/5, which is the intercept of the y-axis. So we can say that slope is equal to 4/5 and the y-intercept is equal to -17/5, or we can write it as a decimal point, so it is -3.1. Sketching the graph, you just draw the y-axis and x-axis, and then you plot the points 3, 1 and the point -2, -3, and then connect them by a straight line. As you can see, it's shown here by the red drawing. Let's take another example. Determine if the line passes through the points -2 and -10, and the second point, which is 6 and -1. So just notice the x-axis and y-axis coordinates in the first point and in the second point, and then check if these points are parallel or perpendicular or neither to the line given by this equation. To solve such an equation, so we need the equation of the line that passes by the 2 points given. Then we have to take the slope of that line and compare it to the slope of the given line by the equation 7y minus 9x equal to 15. Let's first start by remembering the formula. 2 lines are parallel if the slope of the first line is equal to the slope of the second line, or we can say m1 is equal to m2. And the condition for perpendicular 2 lines, that multiplication of their slopes should be equal to -1, or slope of first one is equal to -1 over the slope of the second line. So let's start the steps. So first, find the equation of the line, which is given by the 2 points, and then we use the formula of y minus the y1 is equal to the slope, which is the difference by of y's, divided by the difference of the x's, multiplied by x minus 6, and 6 here is the x-axis of the second point here. And you can see the slope here, which is minus 10, which is y, minus 1, which is y in the second point, divided by the difference of the x's. So x of the first point is minus 2, and x in the second point is 6. So minus 2 minus 6. That will give me the slope. Do the math. You'll get y equals to 9 over 8x minus 62 over 8. That means the slope is the x coefficient, which is 9 over 8 here. So slope m1 is equal to 9 over 8 from this equation. Now you compare this m1 by the slope of the given equation, 7y minus 9x equal to 15, and we put y alone on the left hand side and everything on the other side. So we divide both sides by 7, and we get y equals to 9 over 7 multiplied by x plus 15 over 7. The slope of this line is 9 over 7, which is the coefficient of x. So we have the m1, which is 9 over 8, and m2, the slope of the second line, which is 9 over 7. Now we have to check if they are parallel. We have to find m1 is equal to m2. But it's clearly showing that 9 over 8 is not equal to 9 over 7, which means they are not parallel. And we have to check also if they are perpendicular by checking if m1 is times m2 is equal to minus 1, or if it's equal to minus 1 over m2. So we can see here m1 is not equal to minus 1 over m2. So 9 over 8 is not equal to minus 7 over 9, which is also telling that these two lines are not perpendicular on each other. So it is neither parallel, neither nor parallel, neither perpendicular. Third example, determine the equation of the line that passes through the point 8, 2 and is parallel to the line given by equation, or in part B, where we have if it's perpendicular to the line given by 8y plus 3x equals to minus 2, which is the equation of the same line. So we would like to find the equation of the line that passes by the point 8 and 2 and perpendicular to the line or parallel to the line. So let's start by solving A. When the line is parallel to this line, that means their slope is equal to each other. So the slope from this equation is equal to what? So we take 8y plus 3x equal to minus 2. That means y is equal to, we take the minus 3x on the other side, so it's minus 3x minus 2, and everything is divided by 8. So y become equals to minus 3 over 8 times x minus 2 over 8, which means the slope of this line is minus 3 divided by 8. So if the two lines are parallel, that means the line that we'd like to find its equation and passes by the point 8 and 2 must have a slope minus 3 over 8. So we have the slope and we have 1 point. Then we can find the equation by applying in the formula y equals to mx plus a constant b. Or we can just say y minus 2 is equal to minus 3 over 8, which is the slope, multiplied by the difference of x's, which is x minus 8. We can simplify the formula to find the equation of the line in the form y equals to minus 3 over 8 x plus 5. For the second part, if the line that we'd like to find the equation and passes by the point 8.2 is perpendicular to this line, so we have to find the slope of this line, and which we already found, which is minus 3 over 8. And if the line is perpendicular to this line, that means the multiplication of the slope of our line and the minus 3 over 2, they should be by multiplying them, we should get minus 1, or one of them is equal to reciprocal of the other with a negative sign. So that means the slope of our line, which is perpendicular to this one, should be 8 over 3. So we have a perpendicular line that passes through the 0.82 is, and we use the same formula, y minus 2, we get it from the point, is equal to, we put the slope, which is 8/3, to be perpendicular to this one, and multiplied by the difference of the x's, x minus 8, and 8 comes from this point here. Then simplify the formula, you have the equation of the line. Now, find the intersection point of the two lines, and we have the two lines here, okay, as the first part of the question, part 1 or part 2, when we have two lines here, and in both cases we'd like to find the intersection of these two lines. How can I find if two lines intersect in one point? Two lines can intersect in one point if the value of x and y are equivalent in both equations at that point. That means we have to take the value of the formula of y from one line and substitute it in the other one to find the value of x. Then we use the value of x to substitute it on either of the equations to find the value of y. So we start by, we have here y is equal to this term, and on the second equation of the line we have y equal another formula, but it's mean if y is equal to this and y is equal to this at the same time, so that means at the intersection point this part is equal to this part. So 3x minus 3 is equal to 2.3x plus 4, because this is the junction point, and we solve for x, we find x is equal to 10. You can do that easily by moving x to the other side. So you move 3x minus 2.3x, which gives you 0.7x, and you move the minus 7 to the other, minus 3 to the other side, become plus 3, it gives you a 7. So 0.7x is equal to 7. That means x is equal to 7 divided by 0.7, which is equal to 10. That's how we found the value of x here is equal to 10. Now, if we know x is equal to 10, we can plug it into this, for example. So y is equal to 3x, and instead of this x, we put the value 10. So y is equal to 3 times 10 minus 3 as per the equation, and you solve, do the math, then you get y is equal to 27. So the point of intersection between these two lines is the point where x is equal to 10 and y is equal to 27. So we state that this way by saying this is the intersection point. The intersection point is 10 and minus 7. For the second part here, where we have y is equal to 3x plus 4, and here we have y is equal to 3x plus 8, and again we can see y is equal to some value, and here y is equal to, that means these two values are equivalent at the junction point or at the intersection point. So we have 3x plus 4 is equal to 3x plus 8. That gives us 0x is equal to 4, which is impossible. We cannot find a value for x where we multiply it by 0 and we get a 4. That means this is inconsistent formula where we have x is equal to 4 divided by 0. We cannot divide by 0. So it means we can never find an intersection point for these two lines in part 2 here. If we cannot find intersection point, that tells us these two lines are parallel. Here are lots 3 questions as an exercise for you to train on equation of the line. You can see the first question here is asking you to identify without plotting which of the following functions will give a straight line. So which one of these 1, 2, 3, 4, 5, 6 are representing a straight line and which one of them is not? You remember that the equation of a straight line must be linear, where we have y with no power other than 1 and x should not have any power other than 1, and it should be kind of a formula like this. So clearly we can see which ones are representing straight line, like 1, 2, 3 till C here. What about D here? We have x squared. X squared, that means this is it's not a linear equation, which means it's not a line. Y equals 17, this is linear because y with the power 1 Even if x is not there, that means x has a coefficient 0, so still this is a line. Y is equal to x to the power minus 1. This is not a linear equation because we have x raised to the power, which means it will not be drawn in a line. Question number 2 for you to try to solve. Identify the gradient and vertical intercept of each of the following lines. So now you know these are lines and you would like to find the gradient and the vertical intercept. You can try this yourself, and I'm sure it's easy by putting the formula in, putting this equation line in the formula of y equals to 9x minus 11, which is y equals to m times x minus or plus some constant. Then this coefficient of x is the slope, and this part is the intercept. So for example, for a here, the slope is 9, or the gradient is 9, and the slope and the y-intercept is the, or the vertical intercept is the minus 11. That means this line will cut the y-axis at the point minus 11. You can try the same way for all the other equations. Question number 3 is identify first the gradient and then the vertical intercept, same like the first one, for the following lines. And here you have the lines which needs some little algebraic work to put it in the form of y equals to m times x plus b, where b the intercept. Try it yourself. More questions to exercise and experiment your knowledge, and will help you to gain more knowledge about straight line. I advise you to try these questions, try to solve each one of them. It's if you had any difficulty, you can just take the video back and see the solved questions. Let's go now to the circles and see some few examples about just simple concept of the circle equation. We know that if we have to write down the equation of a circle with a radius m and a center minus 4 and 7, we have to use the formula x minus h all square plus y minus k whole square, which is equal to r square, where h and k are the coordinates of the center point, like minus 4 and 7 here, and the r is the radius value. So we just plug in minus 4 and 7 in place of h and k, and we put instead of r the value 8, which is radius, and we get the solution. So r is equal to 8, h is equal to minus 4, and k is equal to 7. So we'll have x minus minus 4 and everything is square. And please take care of the sign, so you have to put it between brackets like that, so you can see this x minus minus 4, which will give us x plus 4, and then the square here is for the whole term, x plus 4, plus y minus 7, and you see that we have replaced k with the value 7, which is the y coordinate of the center point. Everything also the square is equal to 8 squared. Then you simplify, you get x plus y, everything square, plus x plus 4, everything square, plus y minus 7, everything square, which is equal to 8 square. So this is equal to x squared plus y squared plus 8x minus 14y plus 16 plus 49 is equal to 64. Then you move the 64 to the other side and sum all the numbers here to get you into this form. So you have an x squared plus an y squared plus some x with a coefficient minus or plus a y with some coefficient plus some number here is equal to 0, and this is also the standard formula of the circle equation. Now we have this question which is asking us to determine the center and radius of each of the following circles and sketch the graph of the circle. Each one of them, I'll leave the sketching for you guys, because if you know the center and the radius, it will be easy to sketch the circle. Just plot the center, which will be, for example, x and y, 1 and 2, 0, 0, something like that. And then you go on each of the four direction with the radius. You add the radius to the right, then to up on the y-axis, and left on the x-axis, and down on the y-axis. Plot the 4 points and make the circle. So the most important part here is to calculate the center and calculate the radius, which is the opposite of the last question that we just answered. Now we have the equation, and you can see it's x squared plus y squared is equal to 1. And you can see here, h must be 0. So we have x minus 0 all squared will give us x squared, and y minus 0 whole squared is equal to y squared, and it is equal to the radius squared. So the center is 0, 0, and the radius is the square root of 1, which is 1 itself. So you can answer it saying center is 0, 0, and r is equal to 1. For question number B, we have x squared. That means the coordinate of the center, the x coordinate of the center is 0. And we have y minus 3 all squared, which means the y coordinate of the center is this 3, and radius is equal to the square root of 4. So we got 0 and 3 as the center, and radius is equal to 2. Here, I guess, before showing the answer, you can think about it. What will be the value of the x coordinate, and what will be the value of y coordinate of the center? And then you take square root of 4 of 16 to give you a center as 1. You can see negative. We got here, we have x minus 1, then the center is 1. And we have y plus 4, then the center is minus 4. And square root of 14, which is 4. For question number D, and you can see we have the standard formula for this circle, where we have x squared and y squared, and we have some coefficient for x. And also we have a coefficient of y, and since you cannot see here, that means the coefficient of y is 0. That means the y coordinate of this circle is 0. And the x coordinate for the center of this is some term of the coefficient of x. And we have free number here is equal to 0. So what should we do here? We have to put the x's next to each other and the y's next to each other, and we try to complete the square. So we can have something, x plus something and y plus something, and each of them as a term, as square term. So we have to put it in the form like the equation in the formula number C here, so we can find the radius and the center. So we move it to x squared plus 2 times 4x. We just split this 8 into 2 times some number. Why that? That will make it easier for us to find the complete square for this term. So to have x plus 4 all square, we have to have plus 16. That's why we've added 16, and we have to subtract 16 at the same time from here. But we have 7, so 7 minus 16 is 9, or actually minus 9, and we move it to the other side, it becomes 9. So the whole formula became x squared plus 2 times 4x plus 16 plus y squared equals to 9. Why I've put it in this form? That will make it easier for me to take the x plus 4, 2 times 4x plus 16 all together to make it x plus 4 and the whole term squared. This is equal to these first 3 terms of the whole polynomial or equation. And since y squared is alone and the coefficient of y is 0, so we can take y squared alone equal to 3 squared, which is 9. That means this equation now in the formula same like the one into question number C here. So the center is x plus 4, so the y coordinate of the center is x coordinate of the center is minus 4, and the y coordinate is 0, and the radius is the square root of the right hand side, which is 3. So can you think about the answer of question number E here? What should we do first? Yes, we have to move the x's next to the x square and the y's next to the y square, and we have to add the numbers that make them a complete square. So we do that. So we have x squared plus 2 times 1.5x, and you can see this is 3. We turn it into 2 times 1.5, which is exactly the same value of 3. And here the same thing, we have y squared minus, instead of 10y, I've put minus 2 times 5y. It's exactly the same. So these two here, the x squared and 2 times 1.5x, that means we have to add 2.25, which is 1.5 squared. And also we have to add 25 here, which is 5 squared. But if I added a value, I have to subtract it. So 2.5 plus 2.5 minus 25 plus, then 25 minus. So the first three terms here will give me a complete square of x plus 1.5, everything squared. And this part here, starting from y squared till the 25, all these two terms will give me a y, and this time it will be minus because in front of 2 here I have a minus or a negative sign. So it will be minus 5, everything squared. Then the rest of the numbers, minus 1, minus 2.25, minus 25, put it all in the calculator. It will give you a negative number. Take it to the other side. It will be a positive number, which is 113 divided by 4. So we end up by having x plus 1.5 all square plus y minus 5 all square, which is equal to 113 divided by 4, or 113 divided by 4. From this formula, we can see the x-coordinate of the center, which is 1.5, minus 1.5, and the y-coordinate of the center, which will be the 5 here, and the radius will be the square root of the term on the right-hand side, which will be square root of 113 divided by 2. Why 2? Because we're taking the square root of 4, and that gives me the answer of this one. These kind of questions are easy. So we have questions where we have the formula and would like to know the center and the radius. We try to put them in the formula of x minus h, everything squared, plus y minus k, everything squared, is equal to radius squared. We might find it straightforward, or we might find the formula in standard form and we have to complete the square. Okay, here's some questions like this one. Find the center and radius of the circle, and we have it here straightforward. X squared plus y squared equals 225. I guess this is easy. You can just solve it by actually the center is 0, 0, clearly, and the radius is the square root of 225. I guess it's 15. Now they're asking you to verify if the point 9 and 12 is on this circle. For any point to be on the circle, that means the x coordinate and y coordinate can be easily substituted in x and y in the formula. So you've put 9 in place of x and 12 in place of y, and check if this will give us 225, which is, I guess, true. So the second question, also I want you to try it yourself. Find the center and radius of the circle where we have x minus 2, everything squared, plus y plus 5, everything squared, is equal to 13. I guess this is straightforward because we have the formula, we have the h, and we have the k, and we have r squared. So it should be equal to, yes, exactly. So x minus 2, so the x coordinate of the center is 2, the y coordinate of the center is minus 5, and the radius is square root of 13. Don't forget the square root of the 13. Now try these ones yourself. Yes, you have to complete the square for the third question here. So you can have it at the end as x minus something all square plus y minus something all square is equal to some number, which will be equal to r squared. The last question here is a circle that has a center 0, 0 and a radius 6. Find the equation of the circle. I guess this is easy because we have the center and we have the radius. We can just use the standard formula. Then verify if the point -3 and 5 is on the circle. The same thing like the first question here, we just substitute -3 and 5 on the formula. Another questions for you as an exercise. We have the center, we have a point on the circle, which we know we want to find the equation. We don't have the radius here, but we know that any point on the circle had the same distance from the center, which is the radius. So can we find the difference between these 2 points? Exactly, that is the radius. Then we use the point and the radius to find the formula or the equation of the circle. Another question, kind of a challenging question. You have the AB, which is the diameter of circle C, and the A coordinates are -4 and 3, B coordinates are 4 and -3. We want you to find the center and the radius of this equation. Then show if the point -3 and -4 lies on the circle. How are we going to solve this question? Yes, if AB is a diameter, that means the distance between these 2 points gives us the full diameter of the circle, which is 2 times the radius. So you find the difference between the two points divided by 2 will give you the radius. Take the radius with each or any of these 2 points, either the first one or the second one, A or B, and you can find the equation of the circle. Is point D, which is -3, -4, lies on the circle? Yes, you substitute x and y in the equation to see if it gives you the right value, and you can check if it is really on the circle. Given below the circle x squared plus y squared, which is equal to 4, and the line y equals to x minus 4, and we would like to verify, first of all, we have to find the area of the shaded region, and then find the perimeter of the shaded area. Here is the circle with the red, and here is the line, red also, and the shaded area, which is green here in between them, and would like to find the area of this size. I guess we can find the area, we can find the equation of the circle, which is given here, and we have the radius of the circle. We know how it is, how much is it, which is exactly 2, and then we have the line, so we can find this triangle circle, this triangle area, and subtract this area. We got the area of this. The perimeter we can find it by adding this distance plus this distance plus this, or the length of this line plus this line plus this line. Actually, no, you have to find only this part, and so on. It's easy, can be solved.